So with Harvester 1.7.0, we are building on top of the current vGPU pass-through capability to also allow users to use MIG-backed vGPU devices. What this means is till now, Harvester has only supported SRIOV-based GPUs, which allow further partitioning of the GPU into vGPUs based on time slicing. But for the more sort of, advanced data center or enterprise grade GPUs like the A100s, H100s, H200s, which only support MIG-based partitioning of the underlying GPU, you could not use, vGPU or for these GPU types on Harvester 1.6.0. But with 1.7.0, we sort of, enhance this ability to also allow users to configure MIG profiles on the underlying GPUs via Harvester, and those MIG profiles then map into vGPU profiles. And once that mapping is done, the consumption of those MIG partitions associated with the profiles is very straightforward in Harvester. So in this particular demo, I'm using a A100 GPU on a single node. I already have the add-ons for PCI devices controller and the NVIDIA driver toolkit enabled. I am using the correct driver. In my particular case, for the A100, I am using the AIE driver that NVIDIA ships, which allows the partitioning of the GPU into multiple, vGPUs via the MIG-based profile method. So once you've enabled the two add-ons, the PCI devices controller will scan your node, and within a few minutes, you'll see the PCI devices, network devices, and in this particular case, also the SRIOV GPU devices. Once you enable the SRIOV GPU device, you will see the vGPU devices created, except if you try and use this vGPU device, there are no profiles. And that's because the GPU still needs to be partitioned. Because this is a MIG-backed GPU, you need to partition it. And once you partition it into MIG partitions, the associated profiles will become the vGPU profiles. So in this particular case, when you have a GPU that supports MIG-based partitioning, a new CRD called MIG configurations will be created for your particular GPU. To partition your GPU, it's as simple as reading your GPU documentation, identifying the various profiles available, the maximum number of profiles, for each profile type. So we do a bit of work in the background to query the GPU via the driver to find out the profiles, the maximum available. So the maximum available is just a reference to help you understand what is the maximum available. But obviously, if you create heterogeneous partitions, you will consume all the available partitions in the GPU before you hit the upper limit of the available profiles. So in this particular case, I'm going to create three different profiles, a 1G 5GB, 2G 10GB, and a 3G 20GB. Again, please refer to your GPU documentation to understand how sort of, your GPU can be partitioned and the resources available for each partition. So once you click enable, in the background, the PCI devices controller will make some API calls to your driver, and then the driver will subsequently partition your GPU into the various MIG partitions. So each MIG partition is associated with a MIG profile, and now that MIG profile will be available for use with your vGPU device. So once you've sort of created your MIG configuration and it's synced, we can head over to the vGPU devices section. It can take up to a couple of minutes for the profiles to show up because basically the PCI devices controller will be running regular scans of the sysfs to find changes to the device tree and updating the associated CRDs. So in this particular case, it will find the new profiles, which are backed by your MIG partitions available, and it will update all the vGPU devices. So now to consume those MIG partitions, it's as simple as enabling a vGPU, choosing a partition, and just enabling the vGPU. And now this can be consumed in a VM workload. We can just say, we'll just create a simple VM. And I'll also give some credentials so we can log in and check. Right. So while this VM gets scheduled and is running, we'll create another vGPU device as well. All right, so the second vGPU is enabled, and I can create another vGPU based VM. So now I'll just wait for this VM to boot. So both the VMs are running, and we can quickly check. So we can see that the GPU has been passed, and this can now be used by your workloads. And we can try the same for the second VM as well. All right, so the second VM can also see the GPU, and hope this is a quick demo of how to use MIG-backed vGPUs with Harvester 1.7.0.